मैं राकेश कुमार सवाल सीनियर लेक्चरर गवर्नमेंट पॉलिटेक्निक कॉलेज जयपुर। स्टूडेंट्स, आज मैं आपको सिंपली सपोर्टेड बीम विद सब्जेक्टेड टू यूडीएल ये केस है। इसका हम SFD और BMD दोनों ड्रॉ करेंगे। व्हाट इज आवर प्रॉब्लम? सिंपली सपोर्टेड बीम है AB, UDL uniformly distributed load and the magnitude is small w per meter. UDL होता है पर मीटर, पर यूनिट लेंथ पे अपन इसको शो करते हैं, तो स्मॉल w पर मीटर, दिस इज UDL। तो सबसे पहला स्टेप है कि रिएक्शंस की वैल्यू कैलकुलेट करना। दैट मीन्स RA और RB कैलकुलेट करना। RA और RB कैलकुलेट करने से पहले भी एक स्टेप और होता है, दैट इज साइन कन्वेंशन। वी ड्रॉ ए साइन कन्वेंशन। shear force, if the shear force is upward and it is left to the section, then it would be taken as negative. If shear force is downward and it is right of the section, it will be taken as negative. Similarly, bending moment, if the bending moment is clockwise and it is left side of the section, it will be taken as negative. If it is anti-clockwise and right of the section, it would be taken as negative. This is sign convention. So first of all, we will calculate the reactions RA and RB. RA and RB के लिए जैसा अपने को पता है कि क्योंकि सिंपली सपोर्टेड बीम है, सिंपली सपोर्टेड बीम में तो सपोर्ट्स पे मोमेंट MA और MB वुड बी इक्वल टू 0। क्यों? क्योंकि ये तो या तो ये रोलर सपोर्ट है या ये हिंज सपोर्ट है जहाँ की मोमेंट 0 होता है, तो MA MB 0। तो अपन क्या करते हैं कि या तो A के अबाउट या B के अबाउट, इधर सपोर्ट A और सपोर्ट B, वी टेक द मोमेंट। Why that taking moment? The either RA or RB, one out of these two reactions would be cancelled, would become 0. That's why we take the bending moment about A or B. Take the moment about B. See, we have already studied about this equation, how to calculate the RA and RB. We have studied last time also, yesterday. Again, I tell you that we take the moment about B. Then RA, this is reaction RA. It is upward, multiplied by distance L, perpendicular distance L, because we are taking the moment about B. So distance between RA and B is L. RA into L. It is direction clockwise, section is at B, so left side clockwise would be taken as negative RA into L, plus first of all see that what is the value, then we will let you know about the sign convention. W, this is the load per unit length, so the total length, the total load will be calculated with the help of total length. How? When W is multiplied by, because it is per unit length, when small w is multiplied by total length L, it would be converted into total load, and that is W into L, WL. This is total load. Section is uniform, beam is uniform, load is uniform, so this total load will be taken as acted on the point C, that is mid point. कहाँ पे मानेंगे अपन इसको? इसके CG पर, जो एक्शन यूनिफॉर्म है, लोड भी यूनिफॉर्म है, इसलिए ये इसके CG पर एक्ट करेगा, अज्यूम किया जाएगा, ये मानते हैं अपन कि ये CG पे एक्ट करेगा, और CG कहाँ पर होगा? इसके सेंटर पे, और सेंटर कहाँ पे है? पॉइंट C, कितने डिस्टेंस पे? L/2 पर. So is this UDL would be equal to WL and will act as at point C as a point load. So the value of moment WL, this is total load, multiplied by distance L/2. कहाँ से? इस C से B, सेक्शन कौन सा है? B. तो C से B की डिस्टेंस कितनी है? L/2. So we multiply by L/2. Now we take the direction, we take the sign. Since this is downward and moment we are taking about B, so it will come downward and move towards B, and this direction is anti-clockwise, and section is B. If the moment is anti-clockwise and left side of section, this is the left side of section, and direction is anti-clockwise, it would be taken as positive. That's why we take the positive WL into L/2 minus RB. RB is passing through B, and we are taking the moment about B, so the distance is 0 because the force is passing through the same point about which we are taking moment. So distance is 0, so R into 0. That's why we take the moment about B. And if we take the moment about A, RA would be equal to 0. RA into multiplied by 0, it will again become 0. So RB into 0. So the final value of RA, RB 0 हो गया, RA की वैल्यू निकाल लेंगे, RA into L, this is WL square by 2, RA is equal to WL by L से L एक L कट जाएगा, तो WL by 2 बच गया. सपोर्ट RA और RB टोटल लोड है. टोटल लोड कितना है? W इंटू टोटल डिस्टेंस इंटू WL. RA की वैल्यू रखी WL by 2, RB की वैल्यू आ गई WL by 2. तो RA WL by 2 एंड RB WL by 2. अब अपन पहले shear force डायग्राम बना लेते हैं. We draw the shear force diagram. How? We take the section at B, and we start from left side, support A, taking the section B. RA is upward. If the shear force is upward, left side of section would be taken as negative. RA की वैल्यू कितनी है? WL by 2. We come down by WL by 2. Then this is downward. Load is downward. Section is at B. If the downward load is there, shear force is there, from left side of section would be taken as positive. Upward is negative, then downward is positive. पॉजिटिव लिया तो अब हम ऊपर की तरफ चलेंगे. नीचे आए नेगेटिव में, अब हम ऊपर की तरफ चलेंगे. और ऊपर की तरफ कहाँ तक चलेंगे? जब तक ये कहाँ पे 0 होगा? WL/2. वैल्यू कितनी है? WL/2. तो मिड पे जाके और ये इसको टच कर जाएगा, 0 लाइन पे टच करेगा. बिकॉज इस डिस्टेंस पे जाके जितने हम नीचे उतरे थे उतने हम वापस ऊपर आ जाएंगे, एंड वी विल रीच एट 0 लाइन AB. But UDL is continuously acting up to B. तो अपन क्या करेंगे कि ये UDL जब डाउनवर्ड है और कंटिन्यूस चल रहा है तो हम फिर ऊपर चलते जाएंगे, ऊपर जाते जाएंगे. कितना जाएंगे? वही आधा डिस्टेंस L/2 डिस्टेंस और बचा, तो हम टोटल कितना चल लेंगे, WL/2। हम यहाँ पे आ गए WL/2, कहाँ पे, B पॉइंट पर WL/2 हाइट पे है। नाउ the RB is upward and it is left side of section. We are taking the section at B and we are taking RB left side of section upward. That means negative. That means we will now come down. We will step down. So how much, RB equal to value of RB, and RB is WL/2. We have to come down by WL/2 and V is up by WL/2, and from this point B we come down by WL/2. So we again reach to zero line AB. This is shear force diagram. Fine. This is shear force diagram. Now we draw the bending moment diagram, shear force diagram. I hope you have understood about the shear force diagram, how to calculate the value of R and RB, and how can we draw the shear force diagram. Now come to the bending moment diagram. At moment at A, MA 0, moment at B, MB 0. अब अपन क्या करेंगे कि अलग अलग पॉइंट्स पे मोमेंट निकालेंगे। जैसे L/4 D है, L/4 डिस्टेंस पे पॉइंट D है, यह निकाल लिया। फिर मिड पॉइंट C है, यह निकाल लिया। फिर 3L/4 E है, यह निकाल लिया। और फिर B हमें पता है MB 0 है। तो ये जो मोमेंट्स आएंगे, इन मोमेंट्स की वैल्यूज को हम ड्रॉ करेंगे और फिर उसको स्केचिंग कर देंगे। कैसे? At point D, we want to calculate the moment. कैसे कैलकुलेट करेंगे D पर? D पे कैलकुलेट करेंगे कि RA इंटू L/4, RA इंटू L/4, लोड इंटू डिस्टेंस। ये नेगेटिव आएगी क्योंकि क्लॉकवाइज है सेक्शन के लेफ्ट साइड में। W इज द UDL पर मीटर। तो W टोटल लोड कितना होगा, WL/4 टोटल लोड होगा। कहाँ तक, A से D के बीच में। We are taking the moment about D, so the distance would be taken as L/4 and the load, total load will be equal to WL/4 and it will act at center of this AD, means W means L/8. So multiplied by WL/4 multiplied by distance L/8. That shows WL square by 32. This is moment at D. This moment can be calculated by making a equation. How can we get this equation? Suppose at X distance we take a section. This is section, X distance from A. Now we make the equation of this moment at X, that is mx. How can we get this equation? RA into X, distance is X, RA into X, direction is clockwise, left side of section, that means it would be taken as negative. Then UDL, W per meter, total load WX, because distance is in X, we have taken X distance, section is at a distance X, so WX into distance multiplied by X by 2. Why? because this Wx would act at the center of this x distance. इस A से जो सेक्शन हमने लिया उसके मिड में एक्ट करेगा, ये CG में एक्ट करेगा, इसके मिड में एक्ट करेगा, इसके मिड में एक्ट करेगा, तो x/2 डिस्टेंस बची. तो टोटल लोड Wx into x/2, that means Wx²/2. Direction, because this is downward and we are taking section this, so it will be anti-clockwise, and left side of section anti-clockwise means positive, so we take it as a positive Wx²/2. This equation can be verified by you students yourself. How can be verified? If this is the equation for whole beam, if the value of x, this is x, if value of x put equal to L, we will reach at B, and moment at P is 0. So in this equation, if value of x is L, then the value of m moment would be equal to 0. If it will be 0, that means our equation is correct. And by this equation, putting the value of different x, putting different values of x, we get the different values of moment. If we put L/4, we get MD. If x is equal to L/4, we get the MD. When we put the x value of x L/2, we get the MC, moment at C. And when we put the value of x 3 L/4, we get the ME, and in this equation. So final value, what is final value? Minus 3/32 WL². This will be negative, it will be negative. Moment at C at the center, WL²/8 at E, from a distance 3 L/4 from A, support A would be equal to minus 3/32 WL². So many values of moment we can get by this equation, putting the value of x, and we get the value of moment. So this is the first point, we get this point because it is negative, so we take this point below this line AB. Minus 3 WL²/32, then we take WL²/8, it is here, and WL²/32, it is here, and the MB is 0, MA is 0. So we start drawing the sketch of bending moment diagram of a simply supported beam subjected to UDL, and intensity of load is W per meter. Then we get this bending moment diagram. This is in curve shape. Why this is in curve shape? Why it is parabolic? Because the equation here is equation. Moment equation is quadratic. X square. It is not a straight line. This equation is in quadratic equation. That's why the shape of bending moment diagram would be equal to parabolic. Quadratic equation, the bending moment is a parabolic shape. This would be parabolic shape. This is the shear force diagram. This is the bending moment diagram of a beam that is simply supported and subjected to UDL. The intensity of UDL is W per meter. I think all of you have understood each and everything. That's all. Thank you.